A lot of this stuff is easy pop, Omnivore, like astrophysics. I'm a nerd too. I used to love it to the point where, I would listen to all the latest lectures on, like MOND and, modified Newtonian dynamics and blah blah blah.
Oh, nice.
And then you realize
Oh, yeah.
when you go back to the first principles, right? I didn't want anything that was like a fourth order correction or third order or second order. Just the first principles alone, it's not. There's so many holes in it. So how could anyone just print an article in Science Direct Now or whatever and just be like, yo, NASA scientists have found out that we're in like a glass bubble or whatever the fuck? Like, there's just so much, dude. It's just science fiction.
Yeah, so MOND is tight. Don't often hear people talking about fourth order corrections to gravity. You went way deep into that. That's so cool. Yeah, I don't know. I mean, all of cosmology is a little ontologically suspect, right? It's like we could be way off base. But I also don't think that this animation of the grid contracting in on a planet is like a bad visualization of the gravitational attraction. And maybe the gravitational attraction is a force like magnetism. Like, it's really similar to that. But also the contracting grid is just like a helpful animation. So I don't know. I think people are probably pretty lost as to like where to go next, but like who knows?
I mean, go into like the Michelson-Morley experiment and like the surrounding scientists at the time, like the best scientists in optics and machining and just basically people of the time that made the most precise instruments available in Germany and in some places in like Amsterdam. What was another place? Berlin. I already said Germany. In the UK as well. Dude, they had access to some really unique stuff for the first time ever around that time. And the idea of using interferometry to measure things was huge. It was such a huge, like, that was so big in terms of measurements and like the standards of scientific equipment being administered around then because they needed to. They needed some type of standard because now they were measuring wavelengths of light, which are insanely small in terms of like a digit. So all this around that time, and Nicholson technically failed to find Earth's motion around the sun.
Okay, land the plane and let him get in. I think you got quite a bit of time there, right?
Yeah, sure. Sorry.
Yeah. Well, there
okay,
are some
Omni,
people who.
What's your response, or whatever, whoever?
Oh, sorry.
Yeah, there was a whole lot said, man. I mean, what my response was, a few minutes ago, was we know it's not magnetism because we understand how magnets work. We understand how to detect magnetism, and we know this isn't magnetism. So in the example of the Cavendish style test that I posted, they're using non-magnetic materials. They use Faraday shielding. They're doing it in a vacuum, and everything is grounded. So it takes out all of the typical, arguments about how this could be, this could be electrostatics, or it could be magnetism, or it could be wind. They take all of that out and they get the results predicted by relativity, which is how science works, which is validation for the theory of relativity.
Are all reference frames valid?
Valid for what?
Are all reference frames valid?
Yeah, as far as I understand it, yeah.
So the frame where Earth's not moving, but the sun and the stars are moving, that's valid though, right?
I don't think you understand reference frames.
So it's not valid.
No, it is. So if you say that Earth is
it's either valid or not valid. Is it valid or not valid?
Right. You don't understand reference frames. That's fine.
Is it valid? ZZ Pop said sure.
Anything he tells you, you'll just ignore it and come up with some other shit. So he just gave you something before you asked that question, and it's like you didn't even
Yeah, I mean, I look. QE is really dumb, but he may not be holding the top of the mountain right now.
You can't just give him my answer.
Why you keep on bringing QE up in this, man?
I don't know.
Because Upside Down tried to run QE's dialogue tree, and I saw it. And
Dude, listen. Is it valid or not?
In some mathematical equation, they may give equivalent results in the end, but no, they can't all be happening and true at the same time. How's that?
Then relativity, the postulates of relativity,
No,
where all reference frames are true, is not true. Not true. Then
you're not understanding reference frames. Yeah. So the way that reference frames work, let's say that
any other button that you don't understand
standard speed. Let's say I'm on an airplane.
That's just ridiculous.
Moving at
everything you're saying is just you don't
and I'm
understand.
throwing a ball. I'm sitting in a seat, throwing a ball up and down in my hand. Is the ball going up and down from the reference point of somebody sitting in the chair next to me? Yes, it's going up and down, up and down, up and down. The plane's going 600 miles an hour, but from the point of view, the reference frame of somebody sitting next to me, it's just going up and down, up and down, up and down. However, if I have a point of view from on the ground, and they can see that, they can use some sort of supervision to see that ball is not going up and down. It is moving in a sine wave because it is going 600 miles an hour forward with the plane. So which one of those is correct? Both of them are correct. Both of them are correct, Peter. Do you understand that?
Yes, I understand. Can I rebut it?
Do you understand how reference frames work in that example?
Dude,
that's a yes or a no question, and it's not.
You're possible.
Unlike your question, it's not a trick question.
There, I answered it. Can I respond? Yes.
No, what was your answer?
Is he deaf? I said yes.
Yes. Okay. So yes. So both of those reference frames are valid.
Hold the fuck on. Hold on. Can I respond? Please.
You can now. Yeah.
Okay. So when I said, is it valid to have an Earth-centered stationary frame where Earth is the 0 point? That's the state of rest. That's the what is called the yes. Okay. So that's what is called the inertial reference frame.
It's just one of there are many different inertial reference frames.
All right. So do I understand reference frames now? Can I continue?
No, not really. No, you don't. No, you do not. You don't. But
can I finish my point? Thank you. Okay. So then Earth being the inertial reference frame and taking the celestial bodies, the lights in the sky, as the non-inertial reference frame, that would be valid in relativity. Correct?
No.
Perhaps for the globe, but not automatically for FE.
Holy shit.
Yeah,
right. Are you saying no?
It matters.
No,
it really matters.
Not you, Gabriel. Not you. Omnivore. How are you saying no to that?
Yeah, I'll answer whatever you want. You ready?
Oh, okay. Can I just say one thing?
Not ready.
The relativity postulate that says all reference frames are valid, you would be disagreeing with that.
They're all valid.
Oh, so it is valid. So you're double speaking.
So when you say that the Earth is a inertial reference frame, which you can do, the lights in the sky, the other planets, you say the Earth is still and the lights in the sky are moving. That is a possibly valid reference frame. However, you can also have a reference frame where I'm on the moon and I'm holding the moon. As long as the moon is not accelerating, undergoing proper acceleration, then I can be on the moon. I can say the moon is still and the Earth is moving, right? And I can say the moon is still and the sun is moving. So
yeah, correct.
And
relativity, all those reference frames are valid, right? Okay, so the one that's Earth-centered and Earth-stationary, no, that means that's valid too. You can't just pick and choose. If you're subscribing to relativity, you have to subscribe to the postulates. That's it.
It's not valid. I mean, you could say it, but it would sound ridiculous.
No.
Yeah, like all reference frames being valid is ridiculous. Yeah, all frames of reference being valid is ridiculous. Yes, I agree. But that's the relativity postulate.
So when I'm on an airplane and I'm tossing a ball up and down in my hand, is it ridiculous to say the ball is moving in a massive sine wave in the direction of the plane? Is that a ridiculous thing to say?
No, but it's ridiculous to say when I'm on the moon.
No,
etc. etc.
No, it's the same thing. right? The thing about the airplane is that you can kind of visualize it. Like in your head, you can say, "Oh, I'm sitting in the plane and I don't feel like I'm moving at 600 miles an hour. I don't have a sensation that tells me I'm moving at 600 miles an hour, but I can tell that if somebody was outside the plane on the ground, they would see that ball moving forwards, even as it goes up and down in a sine wave, at 600 miles an hour along with the plane. You can figure that out. But that's how it works for all reference frames. All reference frames are like that. It's no more ridiculous to say that I could be on the moon and say the moon isn't moving
Not in
than it
regards
is
to
to say
rotation.
I'm on the earth and the earth isn't moving. Those are both the same thing. As long as you're not feeling acceleration, and I mean proper acceleration, not coordinate acceleration, but that might be a little complicated, then you can hold yourself as an inertial reference frame.
Bro, you're so biased. You couldn't even say that it was possible or valid. That's so crazy, dude.
Are we
Like,
good now? Can we move on?
yeah.
No.
So all reference frames are valid, right, Omni?
Yeah.
Right?
Preferred reference frame.
Yeah, they're all valid. It may not look to you like you expect it to look from all reference frames, but because like the acceleration thing is something that most people who talk about reference frames don't understand.
What does valid mean in this case? So when one says valid, the other person's ears could mean, oh, it's valid, anything. What is can we be more
You can
precise on
derive
that?
kinematically. You can derive kinematically something's periodicity in motion. Right?
Can
Like
we
you can.
speak a little more for everyone to understand? That was a little advanced.
Yeah. So you're studying things that are moving, right? Kinematics, right? If I look at the sun from Earth, it looks like the sun is moving relative to Earth being stationary. If I were to reverse the math, essentially, where you put yourself, where the sun is, and then vice versa, the Earth is what's moving. That's how you can do it kinematically. It'd be a kinematically equivalent. Therefore,
So,
all reference frames are valid.
So
And
kinematically equivalent do you know do you know what the equations are for kinematics, Peter?
do you really have to I can look it
Yeah,
up.
I do, because I don't think you do.
Does it matter?
Yes, it kind of does. Yes.
Does it
The
help
reason
your
why it
argument
matters,
in any way, shape, or form?
the reason why it matters is because when people say it's kinematically equivalent and they don't know anything about dynamics or kinematics, they don't know. They're making an argument that they fundamentally don't understand themselves.
Okay, do you really want to get into Hamiltonian stuff and a Lagrangian point or energy
if you know what
potentials,
kinematic
gravity
means.
potentials, or
I'm
well,
wondering
I'm
if you know
talking
what
about
kinematic means.
I'm talking about dynamics. I'm just saying, what's the point of this? There's no point to this. There's no point. This doesn't help anybody who's
there
listening.
is. I don't think you understand the argument you're making.
If you say I don't think you understand one more time, dude, I swear to God. Do you have to do that? Aren't you a Christian, Omnivore? Could you stop belittling people? It's very unchristian-like.
He already said it, dude. It's just observation.
Kinematics is measurement. That's all it is, just measurements.
So what's the debate?
It's more than that. I mean, there's definitely formulas to it, trigonometry and all that, acceleration, velocity,
measurement and motion, but
it's purely observations, dude.
A kinematic equivalence is not especially meaningful. It's not. It doesn't. It doesn't mean if I say something is kinematically equivalent, we can't tell. What forces are involved because there's a kinematic equivalent. So who cares? What forces are happening. That's not how it works.
Forces are relevant. With kinematics, forces are relevant. You don't have to invoke forces. That's
kinematics.
That's dynamic. That's dynamic.
Correct. You could have a kinematic equivalence where you're not talking about the forces. That's correct. But that doesn't mean that we can't tell where forces are happening and then go with a dynamic model. We still have to try to explain things in terms of dynamic models.
Well, this is the thing. This is the thing. You can't tell what forces are at play when they're a million light years away.
Well,
Right? You can only kind of
true.
make.
I mean, that's fine. Yeah, I agree. If we're talking about things at the cosmological scale, yes. If we're talking about things on a pool table, no, we can generally get most of the forces in a
Yeah,
building
here on
scale.
Earth, we can know things here on Earth. But like, if you said from the reference frame of the moon, or like if you take a position from anywhere other than Earth, you're gonna have to prove that. Right? You have to prove that. Like, how the heck do you know that the laws of physics apply equally to somewhere like Saturn?
It'd be the
I don't know
opposite.
if we do.
No,
I think it's the
the same
opposite,
as
right?
it's the same as the moon, right?
Same
We've
as the
been
moon.
there, hey?
What's to think? I mean, who's to say that it's different? You have to prove that it's different, I think.
Yeah. I mean, that's the same exact argument.
No, I'm talking to you, Peter. Why are you shifting the burden on Omni?
No. You said you have to prove that it's different. Yeah, you do. You have to prove. You have to prove that they're.
That's a
Sorry.
problem for you. No, that's a problem for you guys.
Yeah.
What? I mean, you can assume that the forces that are going on in Mars.
How do you know the moon
can be
has
the same.
1/6 of Earth's gravity?
Shouldn't do. Should
How
have
do you
like
know-
a 200%.
Wait, what was that question?
Yeah, how do you know that the planets or even the Earth or the sun, for that matter, is in a geodesic? The sun is in a geodesic, experiencing no acceleration, right? Proper acceleration. How do you know that?
So,
All right, how is it free falling in a straight line?
I don't think that you
Around it.
have to know that particular thing per se. You can show that the sun does not exhibit signs of acceleration. For example, a comet, right, has a tail.
Short answer,
Now,
no.
that's because
Ryan.
the solar wind is blowing pieces off of it, and that's what creates the tail. But the point is, if the sun is accelerating in some direction to any significant amount, not in free fall, actually undergoing proper acceleration, we might be able to detect it in, how solar flares behave or things like that. You know where the
What?
acceleration is
Dude.
coming from and how that
What are you
works. But
talking
we
about?
can say we don't see we don't see signs of that.
Mm-hmm.
Right, so it's
Dude, there's-
different than that's what I'm saying. All these things are moving, right, in your model. There's nothing that's actually stationary. You might have like quasi stationary points.
Sure,
But for the
but there
most
are
part,
lots of things
everything's
that
in
aren't accelerating
constant
much.
motion. But everything's in motion,
Free
correct?
fall.
Including the Earth.
Yeah, things are, all kinds of things are moving, but acceleration is different than just motion.
But hold on, unlike on Earth, though, right, where things experience acceleration, everything else is experiencing acceleration due to the bending warping of space-time, right?
Well, wait, no. Things can still accelerate for other reasons. It's not just the bending and warping of space-time. Most
I agree.
cosmological acceleration is due to gravity, but not all acceleration is due to gravity.
No, I understand that. I understand that. That's why on Earth, when we see it, the only acceleration that we see that you guys claim is coordinate acceleration is free fall.
No, that's not the only. Wait a minute. Say again.
The only acceleration that we experience on Earth that's coordinate acceleration would be free fall, where you don't experience proper acceleration.
Free fall is
gravity.
free fall is the one acceleration that is not proper acceleration that we are familiar with. Yes.
But you do feel the tidal forces, though. Like, that's the thing. You feel the gravitational fall. That's different than any sort of change to your motion.
And you can't have continuous free fall without a perfect vacuum.
The 3i Atlas object did experience non-gravitational acceleration.
because of the because of the gas that it was.
Yeah.
Yes.
Yeah.
You know, the moon is that's why we get our tides.
Yep.
Supposedly.
But that's an example of non-gravitational acceleration in space.
Yeah, but how do we know the moon causes the tides?
Well, we
I mean, it's not correlative.
Okay, well, I mean that's a great question. So let's say we don't know the way that science works, right? And this is going to be controversial, but this is in fact how science works.
Do you have to preach like this, dude? Come on.
I know the dialogue tree.
As if no one in here knows how science works. Could you stop patronizing people?
I think that's going to be the contention.
Okay, what's the
how science works?
Yeah, what's the independent variable in testing if the moon causes the tides? Go ahead.
Right.
I'd like to see you try.
Right. I know. That's see. I knew that would be controversial. So you don't have to have
no,
an
dude, I don't
you
care about this stuff.
Let me.
It's just how you speak to people.
Let me know.
How
Let me
you
know
speak
when I
to
can
people.
explain it to you. I'll wait. Go ahead and say your part, and then I'll explain what I'm thinking.
Just stop patronizing when you speak, and I'll be cool with it. I don't mind having a discussion, bro, but just don't say like ad hominems like that, because then that triggers me.
So when Isaac Newton was formulating the law of gravitation, although he did say an apple falling from a tree, a bunch of his writing and other things he said it mostly was about the tides that had, convinced him about mass attracting mass. So we don't have to have, if you look at this here, I'll put the scientific method Wikipedia. It's very, very generic. So you can go look at that if you want to see how science works. I pretty much think it's on target.
QE reference incoming. Beware. QE reference incoming.
I'm not. No. I'm just I'm referencing the scientific method from Wikipedia. It's basic. I think it's not bad. It may not be perfect, but I think it's not bad. So what happens, the way that science works is you have a hypothesis, you have a question or an observation. You research it, you have a hypothesis, and then you test that hypothesis with an experiment. So in this case, the question would be, I think that the moon affects the tides. So if I expect it to work a certain way, can I find a situation where it works not that way? Can I find a flaw with that characterization?
Well, I'll give you an example. Someone was telling me, like about 5 minutes ago, that the Earth's magnetic field is formed because the Earth has an iron core, ignoring the fact that the Curie point of iron is like 800 degrees.
Hold on.
Yeah. That's for a permanent magnet.
Let me answer his question though directly. What about lakes? They don't experience tides.
Good, a great question. So it turns out that tides are heavily influenced by the seabed, the surface of the sea. So yes, certain bodies of water in certain configurations experience far less tides. However, that, at least according to Newton, didn't falsify it because he understood the relationship of tides to the moon. And then when he formulated his theory of gravitation, he was able to come up with a theory. And when Edmund Halley of Halley's Comet used Newton's laws and calculus and Kepler's laws of planetary motion, he was able to accurately predict for the first time in recorded history the path of totality of an eclipse, which was testing the theory of gravity and testing the heliocentric model, and it passed.
Dude, come on.
Keep pointing to like observations without isolating the cause, right? Like you're doing descriptive science. That's fine, dude. I'll grant you that you can do descriptive science where you're not actually claiming to know the cause of an effect.
Well,
you're simply describing an effect, right? At a certain time, right? At a certain geographic location, you're describing an effect. You're not actually isolating the cause, right? You can't assert what the cause is when you're simply doing descriptive science. Now, when you point to pragmatic reasoning, right, or justification for your cause, that's fallacious. Just because you have predictive power doesn't mean that you know the cause of the effect. And you constantly do this. We've told you this probably 100 times, and it's like starting over from square one. Go ahead.
So Zion, let's let's implement this logic about how we find the truth about our reality to the flat Earth and see what fruits has that brought us. On the flat Earth, what causes the tides?
No clue, no idea. We don't make claims.
No,
we don't live on a model.
We have an
But you have
idea.
a computer.
I'll tell,
No, not an
I'll tell you
idea.
what. No, I've got a good answer. Right on the flat Earth, the moon causes the tides.
Yeah, we can say that it's the moon and the sun, right? We don't know what's causing it
Why would you
directly.
say that?
Like what?
Hold on. Why would you say
Because
that?
there is evidence that it's the sun and the but we
No,
don't
you
know.
don't.
We
There's no
can't. We
evidence.
can't say we can't say that it's gravity directly, right? We don't know. We haven't isolated the cause. We can only
You
infer.
can't. So therefore, you can't claim it's the
So-
moon or the sun.
The way that
I'm not
science.
claiming.
No,
I'm not,
what
dude.
it is,
I'm saying
it's
it's
a-
there's a
I wanna
difference.
respond to
Let
the-
the
There's
flat
a-
earthers debate, Omni.
There's a
the way that
difference
the way that the
between-
moon causes the
there's a
tides on the flat
difference-
Earth.
I'm talking. There's a difference between asserting what the cause is, right, with 100% certainty, even though I haven't isolated the cause, versus inferring what the cause might be, right? So I leave it open-ended, and due to the evidence, this is the best inference, right? It's abductive reasoning.
Yeah, I'll tell you what it might be. It might be that the moon causes a weakening of this electrostatic effect that we call gravity.
Yeah, there are ideas that the electrostatic components of the sun and moon could be actually affecting the tides, like above a planar surface Earth. But I was going to say one thing that is definitely connected, or at least timing wise, which seems beyond just a coincidence potentially. It doesn't mean that this is necessarily causal, but it is something that's like cyclically there. Is that, the sun is 24 hours a day, and then the moon is 24 hours and 50 minutes a day. So it's 50 minutes slower than the sun in terms of it making a whole circuit. And the tides change by 50 minutes each day. So like high tide will be at like 4 p.m. one day, the next day it'll be at 4:50, the next day it'll be at 5:40, etc. So it's 50 minutes every day, which is also the difference between the sun and the moon cycle. So that is one thing that is connected. It's just that 50-minute time period of how the high tide will change by 50 minutes each day.
Yeah, and there's a connection to the telluric currents too. Like, there's a whole system. It's not just
Can I
one.
talk?
It's like
Can I
it's
in
a
for a
whole
second?
system.
Can I get in for a
Yeah,
second?
go ahead. Yeah, go ahead.
Okay. All right. So I put in a note and I put in a link to scientific evidence. I think the Wikipedia again does a pretty good job. There are probably other places that you might think do it better, but I think it's pretty good. And when we're talking about scientific evidence as a general thing, it's what I'm talking about. So if you have a theory about how much that ball on that balance beam should move when you put the other orb near it, and it moves that much, and you've measured it and it conforms to what relativity says it should move, that is scientific evidence for relativity. It is not absolute proof of relativity.
Yeah,
it is
I
scientific
gave you that.
for
I gave you that. I gave
yeah,
yeah.
okay,
I said it was.
let me finish up. So that's what scientific evidence is.
Not
That's what it's
proof.
for. And there's not a good reason to believe something else. Scientific evidence is
That's
going to
just
give
your
us.
opinion, man.
Well,
that's
it's also science's opinion.
Yeah, that's when you commit the fallacy, right? Because there's
That's
no
not a
evidence of
fallacy.
anything else. That right there is the problem that I have with
If I
you.
say it can't be anything else,
you're-
that's a fallacy.
That's
Yes.
begging the question / affirming the concept.
No.
When you say that it can't be any other cause.
Yeah,
without
but
ever isolating the
nobody
cause.
is saying there can't be
Now you
any
can
other
do.
cause.
You can hold on, dude. Hold on.
It's
You can
actually
do
an all or
descriptive
nothing
science.
fallacy.
You can do descriptive science.
Nobody is
right?
saying
And
there
use
cannot be any other cause. That's
you
not
can-
part of the scientific method.
You just said that.
Scientific
You
process.
just said that. You literally just said that.
No, I didn't.
Yes, you did, and that's the only problem I have with you. If you left that part out, and you were more open ended with the conclusion, then I'd be fine. You wouldn't be fallacious in your reason. But when you say this can be no other cause, there can be no other cause for this effect without ever once isolating the cause, that's when you commit the fallacy.
Yep. It's just an all or nothing fallacy, bro. Like,
That's not what the scientific
it's
method
it's
claims. That's
classic
not what
begging-
science
it's
claims. I'm
begging the
sorry,
question from the
Beasticles. Somebody has done you wrong.
And yeah, you can do descriptive science. I grant you descriptive science where you're simply observing a phenomena, a natural effect, right? And you're trying to predict it when it's going to happen. And your predictions might be correct. And you might know exactly what's going to happen at a certain time, right? That doesn't mean that you've now isolated the cause, dude. That's descriptive science versus science involved in cause and effect relationships, where you have an independent variable that's you're actually manipulating the cause.
But in this case, you're waiting for the position, the moon's position to change, and then that's your independent variable. You're looking to see what happens to your dependent variable, which would be the height of the tides.
Yeah.
Yeah, that's descriptive science. Like I can tell you, right?
That's not descriptive science. What do you mean?
That is descriptive science.
So Lion is making a reasonable claim that you're not actively taking a step to change that. You're not moving the moon around. You're not rolling it back and forth to see if the tidal bulge moves with it. However, science doesn't require the idea that that is how the good science is done, or the best science is done, or the science that proves things is done is not true. Even if you could do that, it wouldn't prove that that was the only cause. Boiling,
I agree.
people say heat boils water, right?
No,
That's a
listen, I
common
agree.
flat Earth example. I know that I can boil water with heat, but it turns out that when you actually dig into it, with most of the experiments that flat earthers think of, it does not prove that heat boils water.
No, I agree, but that's when it comes to isolating the cause, right? The whole reason.
The flippant answer just turns out to be wrong. Science will never tell you that.
What do you
heat
mean
is
it's
the only
wrong,
thing
dude?
that
Heat boils water.
Okay, are you sure?
Yes, it's not the only cause. That's
Oh
where
wait,
you guys mess up.
no.
Hold on,
Beasticles, come on, man. So if I have
the
water
whole-
and I
the
apply
whole
heat to it,
reason-
it will always boil.
Omni, the whole reason that you have to isolate the cause.
I want to hear this. He wants to do it. He wants to throw
hold
down.
on, Omni. There's a gradient of certainty regarding science. Now, there's a lot of science.
Beasticles, whenever you're ready.
Bro, let him
Stop
talk.
running away, dude. Stop running away. There's a lot of scientists that will confirm, right? I don't know if they're in the chat, that science doesn't prove things, right? You can't actually acquire knowledge, absolute knowledge with science. It is a gradient of certainty or confidence. The reason that you isolate the cause is to increase that gradient of confidence. Now, if you don't isolate the cause, right, it won't be a reliable assertion regarding the cause of the effect, right? Now, even if you have predictive power, right, and explanatory power, doesn't mean that you've isolated the cause or you know the cause of the effect. That's all I'm saying. Go ahead.
Yeah, but here's the thing that you're missing. This is still considered experiment. Like that experiment that I just described, where you're using the position of the moon to and then measuring the height of the tides to build a mathematical model to explain the tides relation to the moon. That is absolutely a proper hypothesis test. It's no different.
I'm not denying that. I'm not denying
Well,
that. You're not listening. You're not listening. Open up your ears.
And
you just said it was. You just said it was descriptive
I didn't think
science.
that's an experiment, and I didn't.
And
I didn't. Hold on, dude. I didn't deny that. Bro, I didn't deny that it's an experiment, dude. I didn't deny that it's an experiment, and I didn't deny that it was science. I specifically categorized it as descriptive science.
Hey, Lion.
It's not descriptive science, though, because
experiment.
you're building up because
you're not isolating the cause.
Can I?
You are trying to isolate for other variables in the experiment that you take into account. Like you look at the different conditions when there's wind, temperature. You try to obviously eliminate as many variables and see if they had any influence on the outcome, right? so that you're isolating to the variable, which is the position of the moon. You state when it starts, when it stops, when you take the measurement, and you make a mathematical model for it. That's not descriptive science. That's purely experimental science. That's no different than measuring. That's no different than measuring the growth rates of
Bro, you're not
bacteria
listening, dude. You're
over
straw
time.
manning me, dude. It's a straw man. Straw man.
I really
right.
Did you
Already,
try it
already
with and
granted.
without the
Lion,
moon?
I'm gonna go to bed
Granted.
soon. All
Hold
right,
on.
can I
Already
wait over
granted
here?
that it's an experiment.
So
Right. Already granted that it's
Hey,
science.
can I just say
Right. But it's
something real quick?
considered descriptive science, bro.
It's
Because
not
you're not
descriptive
isolating.
science.
You're not dealing with. You're not
All right,
dealing with the
guys,
cause and effect
guys.
relationship.
Lion,
You're not isolating the cause, bro. Go ahead.
hold on. They're not listening. Listen, you guys are definitely at an impasse, but okay. Just go one at a time. And Jake, that's all. That's empiricism. That's all you described. If you're not isolating the cause, it's not an experiment.
You are isolating the cause.
It is.
I just explained how you're isolating the cause.
You're
If you don't
observing
do the
something at a certain
experiment
time.
with and without the moon, you haven't isolated the cause.
So, yeah. All right.
Mm.
Well,
Go ahead, Omni.
I mean, I think any
I'll,
theory
I'll,
could
I'll
be
talk about
replaced
how.
by something new.
So, how do you know heat boils water, Beasticles? How did you prove it?
Pressure also boils water.
I took a flame to a pot of water.
And did it boil?
Yes.
And are you sure that the flame boiled the water?
Yes.
How are you sure?
Because I can repeatedly do it.
Okay. What if under some condition you couldn't do it? If it just stopped boiling the water, what would you conclude?
Then I'd figure out the cause.
Okay. So what other conditions have to be true for the flame to boil the water?
Well, you need the flame, so you need
Yeah.
you need fuel for the flame.
No. What other conditions? What other? Let's say there's some other factor that you're not aware of. How are
Okay.
you controlling for it?
Well, you're not aware of it, so how would you control for something you're not aware
Right.
of?
So you don't know that flame boils water.
Yeah.
You just know that in the conditions you tested, flame boils water. Right?
Bro, we already granted you
Right?
that you
Wait,
can't.
wait.
You,
I just
you
want to make
can't
sure we're
acquire.
clear.
You
I
can't
just
acquire
hold on,
absolute
Lion. I want to make
knowledge.
sure. I want to make sure
with
Beasticles is.
induction, dude.
All
Can't
right, look,
acquire absolute knowledge
I
with
gotta go to
induction.
bed. It's late here. If we can't do this,
I'll be back.
You're deflecting, dude. You're
I need to
deflecting.
dip.
Yeah.
Okay, but the
I
point
think
is,
you made a great point.
No, you didn't make a great point because
There's
obviously,
further to go.
according to the scientific standard, you have to
I
control
know,
all the
but
variables.
Beasticles
Which includes atmospheric
just
pressure,
learned.
dude.
He just learned today that he doesn't
I'm not
actually
just
know.
learn. I'm just waiting for people to stop talking.
Yeah, let's
All
just try to go one at a time.
Jesus Christ! Stop trying to fucking belittle me, Omnivore. All right, stop.
Well, then I don't know.
If there's an
You
unknown
might.
variable, I'm going to answer you now.
Go ahead.
If there's an unknown variable that I did not account for in my scientific experiment,
There is.
then yeah, okay. That's
So
why science doesn't prove anything. That's why you have to have a sigma level
So-
confidence about something. Yeah, I
there
get
we
that.
go. Okay, so we
But-
did not.
But
we did not
but that being
prove-
said, that doesn't have anything to do with the fact that you cannot isolate the cause with
you
the
didn't
moon.
do it though. Your experiment, the experiment that you claimed proved heat boils water,
Heat
didn't
boils
do it.
water. I have heat. It boils.
Yeah,
I have
and it
no
boils.
heat. It doesn't
Yeah,
boil.
and you have and you don't know what other variables are required.
Well, but
Okay, so
Omnivore, if you lay that out in the
You
experiment,
just know
like
that
if
heat boils water in this one specific instance. That's
Yeah,
Goes
I
against the
control.
whole argument.
so.
I
Are
can
you aware
control-
that you
listen,
can boil? Right?
listen,
Are you aware that you
listen.
can boil water without heat?
Listen, yes, listen.
Okay, how do you boil water without heat?
Are you gonna listen?
Well,
I'm gonna
hoping that
explain to
can
you.
get-
I'm gonna
can grasp
explain to
this
you
point,
why it's not
but
analogous.
Apparently not.
No, you're just impossible to talk to. I don't even know why I waste my fucking time with you, dude. You can't even like let me respond. Okay. Do you know why it's not analogous to the moon? Because you can control the variable in your experiment. Is it the only variable? No. But it's a very important one because it determines the water boiling or not in my experiment. So just keeping it to my experiment, not bringing in any other outside or unknown factors, okay? I bring heat to water in a pot, it boils, okay? Now however you want to describe that, my control is the heat. I can control how much heat is involved. Can you control how much the moon moves? Can you stop the moon? No, you can't. There's no variable
don't-
that you can control.
This drives me nuts when flat earthers do this.
In the experiments, it's not about controlling the variable, it's being able to vary the variable. Okay. Obviously, there's variables that we can't control, like time. But there's tons of good experiments that we do based on time, even though we don't have the capacity to change time or the flow of time, right? But we can vary the time, just like we can vary the position of the moon in our experiment.
So just so we're clear, basically, you're missing. You assert that heat boils water. It's that assertion in of itself is not true. Heat boils water in some conditions. So
yeah, but Omnivore, can you just lay out?
It's the amount of water and the amount of heat, and there's also stuff about impurities in the water that you may not know anything about. But it's even worse than that.
Omni, please.
The other thing that boils water, of course, is pressure. So under very low pressure, water will boil without heat. Under very high pressure, even with
Omni, you are absurd right now.
But it gets even worse. There's a situation where
I want to know what you
will
would say.
not boil water. You know what it is. You know what the condition is where your heat will not boil water. Are you familiar with that?
Go ahead.
I just want like 10 seconds. I just want to say a few things. Number one, like if you were to, you wouldn't just say heat boils water. You would potentially, if you want to be more detailed, you could say
I need to go to sleep.
at this atmospheric pressure, at this with this type of container, with this type of water, you could say, okay, I have distilled water. I have a metal container that is 2 quarts of size. I have a heat flame that is this size, etc. You wouldn't just randomly say heat boils water. You would actually put down the foundational things like the
room control variables.
Yeah, you would at least lay out the foundational variables, and with that vessel, with that type of water, with that type of heat, and at that atmospheric pressure, that will be consistent, and it's going to happen. Virtually every time, unless tomorrow something changes. So,
right.
And then
you can control all those variables. You can determine where the pot of water is going to be. Is it going to be in a high altitude? Is it going to be in a low altitude? Is it going to be in a pressurized vacuum? Whatever. You can control a lot of different variables. Give me the thing that you can control by observing the moon doing what the moon does.
So I've given you. There is a situation where you can control all the heat you want, and you can't boil
I'm
water.
waiting for you to answer the question.
Yeah, to control the moon, all I have to do is wait, and the moon moves, and then I can see what happens. I can make prediction. I can wait for the moon to move.
But you're not controlling anything in that experiment.
That is how science works.
So you're just
Okay, wait. I'm giving
spiraling.
you a
You're just
citation.
observing.
No, you're overspeaking him. He's not the one spiraling.
You're just
I'm giving you a
observation,
citation.
dude. That's all you're doing. You're not controlling.
You're varying the independent variable, which is all that's required.
What is
and being able to vary the independent variable doesn't mean you have to have physical control over it.
What is the independent variable?
Hold on,
Okay, so the moon.
Yo, just to make sure that you understand what I'm saying, bro. In descriptive science, you can have controlled variables, dependent variables, and independent variables. That's not a problem in descriptive science, right? The problem is you're not dealing with cause and effect.
I'm out here. Can I just say one last thing? Because it's really cool, Beasticles, I'm giving you a citation in the chat. You can look at it to your heart's content, read through it, and find out. You can learn how scientific
I'm
method
giving
works.
you a citation. Post the
Yeah,
fucking
you need
Wikipedia
a
definition of
scientific
scientific
method.
method. Get out of here. Go. Bye.
You'll
Bye.
discover that it
Bye.
doesn't require any of the nonsense that you think it requires.
Bye. Get out of here, dude.
I mean, wow, dude, he makes the VC chaotic. Like he's interrupting everyone. I don't know if he had people on mute, but every time people try to get in, it's like he wasn't even listening. Line, you got completely interrupted. So I guess he just.
I know, dude. We can just bring it down like 10 levels right now. It's gone. Like, I just don't like the way he talks to people. I don't care if you disagree, right? Like, bring up actual arguments. Don't just say you don't understand or you would know this if you did this. And it's like, dude, none of that has any meat to the argument. Like, you're gonna post a citation that you claim is a citation. It's a fucking Wikipedia article page on the scientific method. Like, that's insulting. That's just basically trolling.
It's a form of psychological warfare.
Yeah, he's just trolling, but that's okay. Can we discuss something actually relevant? Go ahead, Gio, and Line.
A lot of interesting people coming through these parts.
Yeah. I don't know. I don't like getting that mad.
Line, do you remember what you were saying? Because you did get interrupted.
Yeah, I'm trying to explain to him that, dude, I agree. Whoever that was talking, that in descriptive science, you can have experiments, right? But at the end of the day, you're not manipulating the independent variable, or you're not manipulating the cause itself. For example, if you move the observer could be the independent variable, right? Its location, his location could be the independent variable. Or if you're growing plants, right? The soil type could be the independent variable. But you're not actually manipulating the cause. You're simply observing and recording, right? What's actually like might be happening. Like, I can predict that the sun's going to rise in the east, and I can put the observer at a certain place and predict at what time the sun's going to rise in the east, right? But by manipulating the independent variable, in this case, it's the observer's position. That's not the cause of the sun rising in the east, right? I'm not manipulating the cause of the sun rising in the east. So you're not manipulating the cause of why or what is causing the sun to rise in the east. You see what I'm saying?
Yeah.
That's Go ahead.
Astronomy and cosmology are like the most limited sciences in terms of like what you can actually do to experimentally test them. And like it is
exactly
interpretive backfilling in. And like, yeah, of course we can't ever say for sure that we've hit the right interpretation or paradigm. Like, I mean, no matter how confident you are, like, I don't see how you would ever
just
be like that.
All right,
Yeah.
then what conclusions can we reach, or Lion, from what you're saying? Like, what conclusions do you think you can reach from what you're calling descriptive science right now in the conversation versus when you can actually isolate, with an actual independent variable that you can manipulate? Like, what conclusions can you draw from each, and what are the limitations or the benefits of each one?
So with descriptive science, you can correlate phenomena, right? You can establish attributes, establish characteristics. You
Find the
can
best patterns.
you can establish descriptions of a phenomena.
Yeah,
Behavior in a certain species in a certain habitat, right? Things like that. Go ahead.
But you can't isolate though down to getting a cause.
Correct.
Like, that would be. I mean, would you call that like proof of a cause? Would you use that term?
No, I don't even know if proof is something that they consider in science, because as a philosopher at heart, I don't think you can use science to establish absolute knowledge or proof. Not inductively, you can't.
Yeah, and it's tricky extra in this domain because it's like the best you can ever really hope for with astronomy and cosmology is just like really
confidence
well
level.
spotting patterns, that are observable in nature, but like you can't experimentally like reset the conditions under which those patterns formed. So it's like it's always going to be a test case of one, no matter how good you get at spotting patterns in the data. Sorry.
Yeah, I want to just say, I agree with Zion in that, yeah, it's in science, and when we're dealing with reality, you can't ever be 100% certain the way that you can be with like philosophical axioms or mathematical proofs, right? Since those are by definition proven, right? As opposed to like even in the experiment, which I think was the point he was trying to bring up before he kind of spiraled, was that even in this test that Fido was left to bring up like boiling water, in the end, you still don't know if the fire is just calling up these invisible water boiling pixies that come and fly in when they see the flame, and then they're the ones involved with exciting the water molecules, right? You don't know that, right? So you're never actually completely sure that there's not something else underlying at work that's actually causing the effect that you think is happening when you vary your independent variable. So yeah, I mean, you try to confound for all the variables that you can, whether you're looking at the relationship between the tides and the moon position, or the temperature of your water, and then trying to compensate for impurities in the water, pressure, atmospheric pressure, and all the other stuff. But in the end, it's still just a high confidence that there's this correlation. But you can never be 100% sure in science.
But you can measure, but there's vapor pressure, and when the vapor pressure equals the surrounding atmospheric pressure, then you start to actually get boiling. So, are you not isolating that the vapor pressure changes with the heat, and therefore isolating that at the very minimum that the vapor pressure is the change in which is essentially causing the water to boil, or one of the seemingly the causative changes, which is what the heating affects the vapor pressure of the water, which then equals the surrounding atmospheric pressure, and then boiling occurs.
Yeah, but what if the only reason why the vapor pressure is going up is because of these pixies, these water molecule manipulating pixies are being called by the fire,
Yeah, but
and that there's certain conditions that would scare the pixies away, and no matter how much fire you were to put in, they would still never
that's
heat the water.
absurd. That's absurd, dude. And as the thing is, like what Omni was saying earlier, he was denying that heat makes water boil, because you can have examples where water boils without heat, which is to me just absurd, right? At sea level, dude, under specific controlled variables, which includes barometric pressure, right? Heat makes water boil, right? If you have a controlled experiment, you have dependent and controlled variables, and the independent variable being heat that you're applying to the water. At every single case, right? 100% of the time, heat will make water boil at sea level.
Yeah, but
I'm
you
gonna have
can't
to
say that with
agree.
100% certainty.
I'm gonna have to agree with Jake on this one. At the base level of logic, like he's right. You can't actually. You can test the fire, you can test the vape, all those things that you mentioned. But at the very, very base level, you can never actually know for sure if you aren't summoning something from an interdimensional, rift to like heat and boil the water that's actually causing the heat from the flame. Like at the base level, Jake's actually right here.
No, I agree. No. The thing is, I agree that induction cannot give you absolute knowledge, bro. And this is an inductive process. I already granted that. right? Because
Yeah.
in philosophy, knowledge, right, truth is eternal and unchanging and immutable, right? For all we know, when it comes to natural laws, scientific laws, they're liable to change over time, right? So what right now, the controlled variables that are in place that allows for water to boil at sea level could change over time, right? Rendering what you thought was an eternal truth no longer an eternal truth. That's the difference between like absolute knowledge that is eternal and unchanging versus contingent truths that might be true today but not tomorrow. But I didn't want to go down that rabbit hole. It's a little complex, but that's the honest truth in my opinion. But most of you guys, maybe Beast is the only one that can relate to what I'm saying.
Yeah.
But all
No,
that
I
I'm
hear
trying,
you.
all that
I
I'm
agree
trying to
with you.
do is this correlation between the position of the moon and the tides, and you compare that to how did it change with temperature, the seasons, this and that, the wind, all those things, right? And then you still see this strong correlation to the moon's position. Is no different than trying to account for all the variables in the boiling water. In the end, we may argue about the physics of it, right? Because if we're talking about, well, how does the fire actually deliver energy to the water, right? And that's through electromagnetic radiation. Is there an ether or isn't there an ether? Is there an electromagnetic field? Like, how is that energy arriving at the water molecules, right? There could be debate about that. And you guys would probably say that about, well, is it gravity that's controlling the moon around the earth and all that? We may argue about that. But just as it's irrefutable that the heat is what is causing the water to the water molecules to gain energy and eventually boil, is no different than the fact that the moon's position is obviously influencing the high of the water.
No, but this is a difference, dude. The reason that you isolate the cause is because there's a gradient of certainty, right? And if you haven't isolated the cause, you have weak observations, dude. That's it. It's a weak observation. It's not as reliable as when you actually manipulate the cause.
We can't remove the moon.
Right. And because you're limited due to the fact that you can't move the moon, all you have left is descriptive science. And then maybe you
But
could
that could still be
replicate that, but you can't.
Well, the
You're
descriptive
varying
science
the independent variable.
It's back to square one, dude. You're unbelievable, dude. Jake, you're something else.
I mean, most of the ladies and gentlemen think he's very reasonable, and we kind of see his viewpoint. So
No, this is fine.
Yeah,
This
but
is how
Jake,
a conversation should go down. Still, I'm just saying. Anyway.
yeah, I agree with that.
Go ahead.
Just as long as everyone gets their time to speak, that's like the most important thing. Because the interruptions, like
agree.
everyone gets frustrated when someone
Yeah.
just gets bowled over, and the next guy gets bowled over, and then everyone's annoyed and upset. And sometimes it only takes one person in the room doing that, and it can cause like a waterfall effect. But in terms of the cause thing, like Jake, you're saying, like you apply heat to water, and it could be like some invisible little gnomes or whatever that are causing. I mean, I hear you. Like, if you're going to get into the nuance of what really is causing it, and then go to the deeper level, what's causing it, and you might even get to like a creator if you're going to go all the way, like what's really causing it all. But at the same time, though, you could still have like a more, I'll call it like a more limited claim of a cause. You could say this heat is causing this water to boil. It doesn't mean that you're getting to every level of every cause, all the way down to it, but you still know that heat causes that. Same thing, like if you add two chemicals together and it creates a third chemical, like do you really know like the nuance of how that's exactly occurring? That could go pretty deep if you're trying to get to the how that's entirely occurring. But you could still say this chemical and this chemical causes a third chemical. Chemical A plus chemical B equals chemical C, and you can do it over and over and over. And you are showing that there is a cause of adding those two chemicals, A and B, that make chemical C. And even though, it could be invisible gnomes or some, a holographic frequency or something else that's doing it, but that doesn't mean you still can't make the claim that there is still a cause occurring, when those chemicals interact, or when you add, heat to water.
Yeah,
I
I
mean,
think
I
all
think
statistics
we
play
agree
into
there, but it's something to think about, Zion. Why in science did we name it an independent variable instead of a manipulated variable, right? If
Because
it's
it's
only an independent variable, if you can manipulate it, we should have just named it a manipulated variable, right? But
no,
that's not what it is.
no,
It just means
it's the
that
step.
we have to have the ability to vary the variable, and
Dude, I'm
in
not.
cases of
Oh
things,
my gosh, dude.
are you just gonna not let me talk? Okay,
You
go
ask
ahead.
me a question, I'll go to answer it,
that.
and you just keep talking, dude. But all right, keep it. Go ahead.
I obviously wasn't done
It
yet,
must have been a
but you can
rhetorical
go ahead.
question.
You can
You
go ahead
asked
and
the
try to predict what I was gonna say. Go ahead.
You asked
no.
me
You
why
asked
do
the
they call it an independent variable, and then you
yeah
just
you
kept talking. But it's all right. Go ahead.
yeah. It's all good.
I'm
I don't know
just
if you
saying.
realize that, Jake. Sorry.
There's
Go ahead.
lots of things in science where we cannot directly manipulate the variable, but we can still use an independent variable because, like in cases of something like time or the position of the moon that comes around every day, right? You can always wait for that precise moment in time to begin and end your experiment and correlate it. And that is still varying the independent variable. You are still varying that variable because that variable
Yes, sir.
is actually changing, even though you don't
Yep.
have physical control to assert over it. And I could do that with like anything in life, right? I could do that with like analyzing car crashes, right? Where I'm not driving the car, but I can wait for a car crash that has the speeds that I'm looking for if I'm
Yep.
conducting some kind
Yes,
of a
sir.
test and say, oh, this car
I
crashed at 50
100%
miles
agree.
an hour. And that was the independent variable. The dependent variable was like, the injuries or the damage to the car or whatever. And then we can build out a strong correlation scientifically, even though we were never driving the car and controlling its speed.
Yeah. I again, I'm not denying any of that. I granted you all of that. That's regarding descriptive science, dude. And yes, you could do it to establish the phases of the moon during the month at a certain time. You can establish all types of characteristics in nature regarding, a certain bonobo ape population that you're observing and you're in the forest as a biologist, right? Doing descriptive science, right? At what time of the year do they mate? Do the female bonobo apes go into heat, right? And then you can establish a pattern, right? And then you can correlate when the female apes go into heat at what time of year. Dude, I have no problem with that. And you can establish the independent variable. You can have a controlled variable and dependent variables. No problem, dude. I give you that. And a hypothesis. Based
So I'm going
off
to
of
read
the
this for you, Zion.
observations, right? You can have a hypothesis of when the female bonobo apes are going into heat at what time of year. And then you can predict and see if your test is correct. And voila, you have predictive power now based off of habitual observations. And you have a hypothesis and you have an independent variable. You have controlled independent variables. No problem, dude. But at the end of the day, right? That's descriptive science. And it's when it comes to establishing a cause to an effect, right? It basically means fuck all, dude.
So I'm going to read this for you. Descriptive science is a category of research that focuses on observing, recording, and classifying phenomenon rather than building mathematical models or testing a specific hypothesis. It is often the first step in scientific inquiry, mapping out uncharted territory before a hypothesis can be formed. It prioritizes accurate, measurable, and reliable facts over cause and effect relationships. So it would be things like studying the migratory patterns of birds, or looking at the
I
different
know,
kinds of
dude.
birds
Bro,
and
I
breaking them
get
out,
that. I already
things like
granted
that.
you that.
Yeah, but what we're
That's
Bro,
doing
everything he's
here
been
is
saying
you
different.
need
already.
to
It's
listen
different
to what
than
I'm
what that
saying, bro.
is.
I'm
We're creating a
granting you all that, dude.
mathematical. In this case, though, we're doing something different, right? Whether we're varying time to study the effects on bacteria, or
Yep.
the position of the
You're making
moon
an observation
and the
and
tides.
and then the correlation.
Yeah, I'll give you that.
We're recording and building mathematical models and hypothesis testing. That is no longer in the field of descriptive science.
That's still descriptive science. All of that, it's still descriptive science. It's observational science at best, dude. But I'll give you it. I'll grant you it. It's fine, bro. It's part of science, the umbrella of science, dude. You can have that. That doesn't help your cause, pun intended.
Yeah, it's just the observation and correlation, no experimentation.
In the end, it produces fruit. And so
Or
far
liver
on the
fruit.
flat Earth, we have very little fruit. We still don't know what causes the phases of the moon on the flat Earth. We don't know what asteroids are or comets are on the flat Earth. We don't know. I mean, we don't know how far the sun is, how big the sun is, what the sun is made of. We don't know why we see the same face of the moon everywhere on the flat Earth. Like there's still, it doesn't seem to be using
know the Earth
the
is
flat Earth
stationary.
methodology for discovering our reality doesn't seem to be producing much fruit.
We know the Earth is
No map.
stationary.
We still have no map.
Your reality's done, bro.
How many
I
paradoxes
know,
are there
too.
with relativity?
What's
You
that?
act like relativity doesn't have any paradoxes.
Yeah, it doesn't have anything at all. Doesn't have anything that you can come in here and argue about, right? Because nobody wants to talk about the science created by flat Earth reasoning, right? Because there isn't any, right? It's just a bunch of mysterious. Oh, it's a mystery. The moon is a mystery. It's an enigma. Oh, what's Jupiter on the flat Earth? Oh, it's just a hologram in the sky. Well, what are the moons that orbit Jupiter and cast shadows on Jupiter?
So
It's
all you
just a
have,
big
Jake, is
mystery.
all you have is just a set just so story. And by the way, I have a citation here from NIH.gov says, certainly no developed science is merely descriptive in the narrower sense of the word. It seeks to explain. So saying that you can have descriptive science is not a science. It's just something you could just observe and declare. You have no causation. You have no way to explain. You have nothing to vary. So saying that, I can have descriptive science, you have nothing. You have a just so story.
Can you define science for me? Can you just do a definition just for science?
You
The
gotta
word science.
land on the moon, walk around, video.
Yeah, just
But
go
yeah.
ahead and read the definition of science for me, so we all know what it is.
Yeah, but did you do your prayers before you sleep at night? All right.
Hold on, he was asking Elbo, I think, if Elbo wants to answer.
If he's saying descriptive science isn't science, so I want him to go ahead and just cite what defines science for us. Go ahead and read the definition for science. Is he not going to do it? Or are we not going to bother to read the definition of science if you just claim descriptive science isn't science?
Science or knowledge of object or process observable in nature as biology or physics and distinguished from the abstract or theoretical science as mathematics or philosophy.
Okay. I mean, that's a fairly reasonable thing. So in under that context, how is descriptive science not science?
It has is any process you could do on natural science? I mean, in descriptive science. What are you doing in descriptive science?
Like if I wanted to figure out how a certain animal reproduces, and so I just observe it and then I watch it reproduce, and then now I know how that animal reproduces. That's not science. That was just completely observational, right?
You're observing something doesn't mean that you're actually doing science. You can study anything. I mean, you're definitely studying. You're studying their reproductive, the way they reproduce or whatnot. But you can't call it science.
See, the more common definition is science is a systematic process of gathering knowledge about the universe and the dynamic, evolving body of information that results from it. It relies on observation, experimentation, and evidence to explain how the natural and physical world works.
Keyword experimentation.
So what is that? Yes. So where that part says is just observation or describe?
That's just one part of it.
Well, I mean, it's the
What's
gaining
that
of
systematic part though?
It's the gaining of
Systematic
natural.
just means that that you're consistently applying it.
What is that though? Systematic process. Which one is it? What has been established for that?
I mean, if you don't think, here's the funny thing: is all the
So
stuff
don't want to answer.
all the stuff that you've learned in your life about reality, you haven't been doing hypothesis testing of, right? Most of it was just observational.
Right, because I'm not doing any science whatsoever. I could definitely. That's what I'm trying to say is that you don't have to do science to be able to acquire knowledge. But
we just go on
if you're claiming something in science and you're not going through the scientific process, it is definitely called pseudoscience.
Okay, so what you're doing here is you're trying to squeeze science into this little box of what flat earthers consider science, but you're totally fine with saying that, hey, just observing the world around us is still a completely valid way of building more understanding about our surroundings, right? You still agree that's how you've learned almost everything in your life. You haven't been hypothesis testing all the things that you've learned. Most of it is just observing, right? And you agree that that's a completely valid way to gain knowledge about our reality, but you're saying, but that's not science. When the whole goal of science is to gain knowledge about our reality, but yet you want to somehow shackle it down and say, oh, no, it's only quantum eraser's definition of science, where you got to have a hypothesis test
let me step on for a moment.
and the independent variable, you have to be able to directly manipulate it yourself, like all this stringent rules, otherwise you can't build knowledge about our world. It's so ridiculous.
Let me step in on this definition for just a moment. Right, like science is about gaining, so it's about the gaining of wisdom of the natural world or the natural phenomena. Right, so it relates directly to cause and effect of phenomena.
Hey Jake, when you were saying this whole thing, and someone saying that they can't derive any knowledge from the world because of the cause and effect thing, I haven't heard anyone say that. I think it's about deriving a cause. I don't think anyone said you can't derive some knowledge from these other things. Like Elbo, are you saying you can't derive some information even if you don't have an independent variable? I thought more it's just that you can't derive a cause. You could still glean some information from it, but it's not. I don't think anyone's saying that, like, if you don't have an independent variable, you can't get any knowledge about anything, unless someone is saying that. But I think it's just if someone's saying, hey, the cause of this is X, Y, Z, that's where it gets into, wanting to be rigorous about that. Because someone's coming in here and saying, hey, I know the cause of whatever. It's Earth rotation. And then it's like, okay, well, now you're claiming a cause.
Yeah, but we can still derive a cause without being able to vary it ourselves, right? We can just observe it and then and wait for it to naturally move into different variables. Like I used the example of analyzing different crashes that happened at different speeds. Even though you were never in the car, you never drove it, you never controlled the speed. You can just say, okay, this is the amount of damage or this is the amount of injuries related to speed, and then you can make a very reasonable assessment that the degree of the damage to your vehicle or the degree of the injury to the occupants is based on the speed of the impact, based on analyzing that data, even though at no point were you manipulating that variable.
Amazing. You didn't do science. Great.
But you can
that's not science. If it's not your definition of science, who cares? It's still incredibly valuable, useful information about our reality.
Yeah, no,
you're only choosing not to call it science.
What
Anyone
happened
that's
to the
in
car.
the sciences, okay, I was still talking. And
Sorry,
you're just,
it sounded like you were done, but if you have more, but it sounded like you were done.
All right, you guys decide.
Go ahead, though. Sure. No, if you weren't done, go. I mean,
yeah, go ahead. I thought you were done. That's why I started talking.
It just seems ridiculous that you guys are saying, well, that's still useful and great information, and it's true about our world, but it's not science. It's just dumb because anybody in the sciences would agree that is still science. Analyzing crash data is absolutely science.
No, it's not. Definitely not.
All right, type in any AI engine.
This is why Lion was saying you can
type this into any AI engine, and we could put $1,000 on it right here. I will pay Bitcoin tonight. That in any AI engine, it will agree that doing a systematic analysis of crash test of crashes and injuries is science.
All right.
So with that, I guess, Jake, you'd agree that flat earthers do perform science.
I
by
mean, I
trusting
haven't.
our
I've
observations
seen.
and our
Well, look,
correlations and inferences.
I think.
Yeah,
I think.
but this is
I
why.
think
Can I
the,
just say, this is why Lion was saying you can infer if you're just going to observe and watch things and make correlations and so on. So that's why, like, what do you think when Lion was saying that it's more of an inference, which is like you're using some information to try to figure out some other information, but you don't really directly know it. You don't really directly know that it's the cause, but you're just inferring it. Like, oh, when the moon does this, the tides do that. You can build a whole model based on that, and you can feel like you're extrapolating information, but do you really directly know it? And then if someone's going to say, hey, we directly know the Earth is a globe or the moon's causing tides or whatever, that's when people are going to hold the feet to the fire oftentimes with that. Like, okay, well, how are you claiming you know that? If you're just coming in and saying, hey, we're inferring it, we have some ideas or we're using this information to kind of link it to this other information and we think it's getting us somewhere. But then that's more of a philosophy, and somebody else could just disregard that and say, I'm not a fan of that philosophy. But if you're going to make a claim that like of what direct knowledge of something, that's where getting to a cause and effect, is going to be much more like you don't have to only go off inference if you actually have a cause and
there's
effect.
always.
And then when the term science and how that's being used, that's where there's going to be debate on, where that falls.
Wouldn't you agree, though, Gio, that there is always some inference involved in any science? There is never a situation where there isn't at least some degree of inference.
Well, what if you're isolating the cause of an effect? That you do directly know that this chemical A plus chemical B causes chemical C. What do you have to infer for that?
I mean, look at the definition of inference, right? It's being able to draw a conclusion based on what you're seeing, right?
Well, you could look at the similar cyclical patterns of the moon and the tides and say, oh, the tides are causing the moon to do what it's doing, right? You're just inferring things with no experiment.
Sure, but you'd have to have a bigger framework to kind of try and explain how the rising water is causing the moon to move.
Can I just jump in real quick here? I think the problem is that Gio actually kind of hit it on the head with what he said, is that you're being taught that this is all fact. You're not being taught like, oh, it might be this. I mean, we've done all these experiments and they work, but it might be this. It's not taught that way. Everything is this way. And I think if people weren't pigeonholed down a certain line of thinking and their minds were able to just express themselves naturally, they might arrive at a completely different solution that might work out better than where we're at.
Yeah, it's taught as fact and is brought up as exclusive evidence, right? And then when we look into it, it's not exclusive. It's not a fact.
Yeah, and actually linking right to that, I was looking up Merriam-Webster just to see which definition of inference would be interesting. So this one kind of links to what we're talking about. This is the definition: the act of passing from one proposition, statement, or judgment considered as true to another whose truth is believed to follow from that of the former. So that's a pretty good way to sum it. It's like, okay, one thing is true: the moon is in this position, let's say, and then using that to kind of extrapolate that something follows from that. Oh, and then therefore it's caused by the tides, or any number. Oh, this Cavendish, okay, these torsion rods and the balls, and you get this little bit of motion, or this little bit of let's say attraction, just for the moment. And so that is one thing. And then you're using that to kind of extrapolate another piece of information that you think is following from it. But that's where assumptions get involved and possible bias. And then when we're getting into this definition of science, are you really isolating anything with that? Or is it like a inference sandwich, like one inference after another? Oh, this one leads to that, and we think this leads to that, which is what goes on. Like they claim to get big G from Cavendish, and then what follows from that is little g, and then that incorporates the assumption of the radius of the Earth, which is then claimed to be a globe. So now you have the radius of a sphere, and you have the big G from Cavendish, and then extrapolating little g, and then everything else that comes after that. But there's a lot of one thing following from another when it comes to that. And I think a lot of people are going to put their foot down and say, hey, that's not scientific. That's not rigorous and so on. It's still something, but it's extrapolating, that one thing follows another. You have one thing is the case, or you've observed an observation of something, and then you're saying this other thing follows. Like, oh, the pendulum does this drifting. The pendulum does this drifting thing, and then this other thing is following. Now I'm going to say it's because the whole Earth is a sphere and it's in motion. It's another example of it.
Right. And in the case of the boiling water, we're applying heat. We're watching our thermometer rise up. The temperature is increasing. You're first of all saying that, okay, this mercury expanding in this tube means the temperature is going up. And then after it goes up to some certain point, the water starts boiling. So first it's that thing, and then something else. First you apply the fire. You make the inference that the fire is going to excite the water and give energy to the water, and the water is going to start heating up, and you'll know it's heating. You're inferring that the water is heating up because the mercury in the thermometer is moving. And then at some point you observe it boiling, and then you have to make the inference that when it gets to a certain temperature, the thing that follows before and then follows after what you just read, it's absolutely inference involved in that, which you consider to be your rock solid example of a perfect scientific experiment.
Well, I didn't make those phrases. I was just talking about when you can, when you have an independent variable that you can isolate a cause. I didn't necessarily say those last words you just said there, but just the difference of you can isolate a cause. And I think you would probably agree, let's just say with real quick, the pendulum thing, if you could stop the motion of the Earth and then the pendulum wouldn't precess and then you could start it back up again, wouldn't you agree that that would be a lot more powerful because you are manipulating something? You can tell, oh, you manipulate it, it stops. You manipulate it again, it starts. You manipulate it, it stops. You put it at a different speed, it goes at a different speed. Wouldn't you agree that having that level of control is something different than just observing it and then making an inference based on that? Because what you said there, that word inference could be used for what you were saying there, in a maybe different context, but I'm not, because words can have multiple expressions. So one thing is following the heat. You put the heat on, you're using that truth or information that, oh, now the water's boiling. I hear what you're saying, but when you can isolate, when you can control it, that's the difference in terms of this current discussion.
But you
when
don't
you can
even
control
know.
it, when you can control it, you can indicate, oh, when I turn it on, it happens. When I turn it off, it doesn't happen. On, off. Otherwise, when you're just observing and then you're watching, other things that correlate with it, it's the whole correlation is not causation.
Yeah. But so basically in that, it's the correlation is that because you can't actually tell that the water is getting hotter. I mean, sure, you can say that it will burn you. You could also say that, oh, well, it's getting hotter because it's causing this liquid in a tube to start growing in size. And so then you're saying, okay, well, if the tube in a liquid grows in size to a certain amount, then the water will boil. Right?
Well, I'm going to jump in. There's an inference you could draw. Tides are strongest when there is a full moon, right? And so we know that the sun heats things. There's an idea that the moon cools things. So how do we know it's not just a heating and cooling effect that's causing this swelling and migration of water?
There's never been an experiment that actually shows the moon cooling anything. It's nonsense.
Now you want to experiment?
Go ahead and show me the scientific experiment of the moon cooling things.
I thought you didn't care about experiments.
No, I'm the one that's arguing that there's lots of valid ways to do an experiment. What do you mean?
Well,
You guys are the ones that are
arguing
saying that
against
correlating.
Now you're demanding an experiment.
The whole night I've been arguing that there's lots of valid ways to do experiments. That's been my whole thing all night. And now you're saying that means I don't like experiments?
Well, we're telling you're presenting a horrible experiment with the moon causing the tides, right? It's just the inference and the correlation. You don't have a problem with that, but then you're demanding that guy to give you a perfect experiment.
Yeah, you're boiling water. You're influencing how much liquid in a tube is growing in size to water boiling.
Yeah, did anyone I don't. So what's the problem with that?
Nothing.
Well, it's just that you can isolate what the cause is. I don't know what you mean by tube. At first, I thought you were talking about a barometer, but I guess you're not. You're talking about boiling water, because the thing is that but when you apply the heat is when the water boils. So there's a cause and effect.
It doesn't happen right away.
You could
I mean,
look at the water without the heat and then with the heat and look at the changes, right?
If I
Can't
set
look at the
my
Earth with the moon and without the moon.
if I set my burner low enough, the water will never boil.
I mean, you could test this. There is a way to test this, right? Like I've seen experiments where they have a thermometer that's not covered and then it's exposed to moonlight, and then another one where it is covered. Right, there's a temperature difference there, but you could say that, oh, that's because it's got the cover on it, so it's dissipating less heat. But then, so you could make like a tube or a sealed tube, and then have it so that it tracks the moon and that it points at the moon all the time. And then you'd have another tube where it doesn't point at the sun, at the moon.
But yeah, Jake, you're spot on. You could, if you don't put a lot of that flame on it, it's not going to boil, right? So you can directly test that relationship, right? Whereas with the moon, you can't, because you can't look at the Earth with the moon and then without the moon.
Yeah. So when I put it at first, when AI, of course, AI could definitely give you all kinds of shit that agrees with you, and you could change his bias. So yeah, Claude told me, yes, it is science. Okay, so when we started going down to the steps, is there a natural phenomena? It's like, well, there's weather, Okay, but what is the natural phenomena? Does it has human intervention? Yes, according to human, it does have human intervention. So therefore, it doesn't fit the natural phenomenon. So therefore, it can't be natural science.
I don't know where that's coming in. Humans are part of the
I'm talking
natural world.
Doesn't matter, but in the scientific method, you have to observe a natural phenomenon. Meaning, in the definition of natural phenomena is something without human intervention.
Doesn't it mean not supernatural?
Ain't nobody talking about supernatural. I'm saying we're talking about natural phenomena. We're talking about natural science. We're not talking about the supernatural world or anything like that.
But if I do science on a man-made object, that the phenomena is all natural still, even if it's a man-made object. We're not creating new phenomena.
If it has human your first observation has to be from a natural phenomena, which requires it not being human, any kind of human intervention to cause that natural phenomenon. Because therefore we know the actual cause, which is human.
Like putting balls in a shed?
Exactly.
So then lasers aren't science then, right?
Yep.
Because there's no lasers in nature, right?
Yep. Who's doing a natural phenomenon with lasers?
Nobody. There's no natural phenomenon of lasers. So therefore,
Right, so
lasers aren't science.
Yep. Who's saying that
Right?
side is science?
So if lasers aren't science, what are they?
I mean, what are they? They're a man-made object.
Are they pseudoscience?
No, it's engineering. What are you talking about? They applied science. They apply it, but it isn't science.
But it's not
basic meaning
science.
of the term.
Yeah.
I mean, it's light. There's light in nature.
Yeah, that means you get what you learn in natural science with natural science, and then you apply it. You call that applied science. Just like software engineering isn't science, but it's applied science.
And so I guess material science isn't science because those are all man-made materials in material science, right?
Yeah, well, that was